In 8.1 part 2, we're just going to practice graphing some. So here is example 8b. So the first thing you want to look at is, what is it? It's a cosine. And so the parent cosine 5 points are going to be your guide. So the cosine goes 0 is at 1, pi over 2 is at 0, pi is at negative 1, 3 pi over 2 is at 0, and 2 pi is back at 1. Now, those are our guides. So what do we know? Well, this outside number is on the outside. It's going to affect our y, and the absolute value of negative 0.8 is our amplitude. So our amplitude is 0.8. Now, what does that mean? Well, the fact that it's negative means that there is a flip. What the 0.8 means is normally our bumps, as you can see in the cosine, goes up 1, down 1, up 1, down 1. Now it's only going to go up 0.8. Okay, next. Let's talk about phase shift, vertical shift, all those shifts. If there was a phase shift moves it left or right. So you set the inside parentheses equal to 0 and you solve. So there is no phase shift for this graph. So we've done this part and we've done that. Let's talk about the period. The period, you set your parentheses equal to 2 pi and you solve for x. So that's going to be pi, that's our period. That means this graph got kind of smushed a little bit, and so it finishes a wave in a pi instead of stretched out to a 2 pi. So we've done that. Now let's talk about the midline. Technically, I could rewrite this as the cosine of 2x plus 0. That tells me that the midline is at y equals 0. Okay, so that's our vertical shift. So it's kind of midline and vertical shift are the same. So now let's figure out what x's we need. Now remember, you set the inside parentheses equal to your 5 good ones. So where will 2x equal 0? Where will 2x equal pi over 2? Where will 2x equal pi? Where will 2x equal 3 pi over 2? I didn't give myself enough room. And where will 2x equal 2 pi? Well, you notice for each of those, you were dividing by 2. So this is 0, pi over 4, pi over 2, 3 pi over 4, and pi. Now, if you notice they're counting by pi over 4s, good for you. But if you have to do all 5, do all 5. So our new x's are 0, pi over 4, pi over 2, 3 pi over 4, pi. So along my x-axis, let's count here every 2 as a pi over 4. It looks like I can stretch out to a negative 2 pi to a positive 2 pi. Now, as far as my up and down go, we only need a 0.8. So let's make this 1 and this one negative. Okay, now how do you find the y's? Well, remember, wherever the cosine is sitting, think of that as negative 0.8 times the y, the good y, plus 0. Now, you didn't have a plus 0 there. You don't need it, but okay. So we're going to do 1 times negative 0.8 is negative 0.8. 0 times that is 0. Negative 1 times that is positive 0.8. 0 times 0.8, negative 0.8 is 0. 1 times negative 0.8 is negative 0.8. Now we're ready to graph. Okay, so at 0, we are at negative 0.8. At pi over 4, we're at 0. At pi over 2, we're at 0.8. At 3 pi over 4, we're at 3/4, we're at 0. And 1 whole pi, we're down at negative 0.8 again. So this is half of a bump, bump, half of a bump. A cosine usually becomes half bump, bump, half bump. And then let's keep it going so we can make this pretty. So just finish off the bump, spread your graph paper out. Each bump should be the same width and the same height each time going up, same height each time going down. Okay, so there is example 8b. So the inside stuff changes your x, the outside stuff changes your y. Just like any other one, it's just you got some pi's and fractions to deal with. That's an example 9. Now, it didn't say to do all those pieces and parts, but let's just analyze this for a minute. That 3 is going to change the height of the bumps, so the amplitude is 3. This is going to change the period of the graph. This whole thing is going to kind of shift it to the right because we've subtracted. So this stuff will affect your x's. The 3 is the only thing affecting our y's. So what do you got to do? Well, let me write the 5 good ones over here. You'll notice I'm going to think about those every time. For the sine function, it goes 0 is at 0. Pi over 2 is at 1. Pi is at 0. 3 pi over 2 is at negative 1. 2 pi is back at 0 again. So we're going to set that whole parentheses equal to each one. Now let's start with 0. We're going to add pi over 4. You're going to divide by pi over 4. So our first x in our new stuff is 1. Now hopefully the next one comes out nice so that we can see it's because they're equal spaced apart. Okay, so the next one, pi over 4 x minus pi over 4. The whole parentheses equals pi over 2. Well, pi over 2 is a half of a pi. If we add that pi over 4 to it, we get 3/2. I'm sorry, 3/2. 3/4. And so we get pi over 4x equals 3 pi over 4. And then if we divide off the pi over 4, we just get the 3 is the only thing left. So we know now the equal spacing. So the first one's 1, then 3, then 5, then 7, then 9. So once you know the spacing, it's an equally spaced wave. It's kind of symmetric, but eh. Anyway, what are the y's? Well, it's just 3 times the y. The y is the sine. So we just have to take the y's from the original chart and multiply them by 3. So this is going to be 0, 3, 0, negative 3, and 0. So that was easy. So we need our graph paper to count by 3. So let's go 1, 2, 3. 1, 2, and there's negative 3. Okay, and then let's count. What's great about our x's now is it's just going 1, 3, 5, 7, 9. So that's awesome. So let's make that 1, 2, 3, 4, 5, 6, 7, 8. Let's spread it out a little bit. 9. Okay. Now, let's put our graph on there. Okay, so at 1, we are at 0. At 3, we are up at 3. At 5, 1, 2, 3, 4, 5, we're back at 0. So there's a bump. And then let's go at 7, 5, 6, 7, we're down at negative 3. And 8, 9, we're back up. And then we could go the other way. 1, 2, 1, 2, 3. Up there, we are up here. We're down. I'm sorry. And then that right? Just a second. I think I'm scooched over a little bit. So it'd be right here. I'm sorry. And then right here, we'd be back up. And then 1. And then we'd be back up here. And then 1 we'd be back down there. Okay, so I think that's pretty good. So you can see we are at a height of 3. Our sine function was right here. It's kind of scooched to the right a little bit, and it's counting in a way that we normally wouldn't. You notice it's like 8 is our period, and normally our period's 2 pi. So it's kind of been, the x's have been changed dramatically. Okay, so there's example 9. One more. Let's go through everything. So the amplitude, the absolute value of -2, or 2, and there's a the period. We're going to set just the x term alone, not the whole parenthesis, just the x equal to 2 pi, and we're going to solve. We're going to set the whole parenthesis equal to 0 to find our phase shift. Going to solve. Our phase shift is pi over 2, so that's to the right. Horizontal shift is this value right here. It's y equals 1, which is our midline. Okay, now they want us to graph it. So the cosine normally goes like this. 0 is at 1. Pi over 2 is at 0. Pi is at -1. 3 pi over 2 is at 0. 2 pi is back at 1. So we're going to set the parentheses equal to the 5 good ones, 0 pi over 2, pi, 3 pi over 2, and 2 pi. Now let's try the first 3 and see if we can find the pattern, the spacing. Okay, so 2x minus pi, that's 2x equals pi. Oh, we already did that. That's pi over 2. That's your phase shift. That's the first value always. And then 2x equals 3 pi over 2, so that's 3 pi over 4. I'm sorry I'm going a little fast. You might have to pause it because the bell's going to ring shortly. We're counting by pi over 4s. The next one, if you do it, you're going to get pi, and then 5 pi over 4, and then 3 pi over 2. And that's all of them. Now what the y's are. It's going to be -2 times the original y's plus 1. So we get to use this chart. So 1 times -2 is -2 plus 1, which is -1. -2 times 0 plus 1. -2 times -1 is 2 plus 1. -2 times 0 plus 1. And -2 times 1 plus 1. Okay, and these two match. Now let's graph. We're going to count by pi over 4s. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. That's pi. So think fractions. Those are fourths, pi over 4s. And then up and down, I'm just going to count by, well, let's go every 2 space sets. Okay. So at pi over 2, which is right here, well, no, let's put our midline on at 1. It always helps us to see where we're at. So you always keep coming back to the middle. Okay, so at pi over 2, we are at -1, right here. At 3 pi over 4, 3/4, we're at 1. At pi, we're at 3. At 5/4, which is 5/4, we're at 1. So there's the, and then we should get another half bump at 3/2, which is 6/4, which is right there, we're at -1. Okay, and then we could keep going up, up, down, up, up. There you go. Sorry, that's trying to go fast. I'm not good at fast here. Okay, and stretch that all, keep that pattern going. So there's example 10. And this is not due till Saturday. Get started on it. I might change the numbers a little bit, and I'll let you know about that. But for now, problems are 17 to 25 off. Okay, there you go. Thanks.